Hi everyone, in this video I'm going to show you how to do Python data visualization in Jupyter Labs with Pandas and Pywedge charts. To begin this process, I'm going to get a free dataset from data.gov. With data.gov, you have so many datasets that you can use for your projects. Here is the homepage for data.gov. Here you will find data, tools, and resources to conduct research, develop web and mobile application, and design data visualizations. In this case, we are going to be getting a free dataset to use in demonstrating Python data visualization in Jupyter Labs with Pandas and Pywedge charts. I'll just type telemedicine and hit search. This will give me all datasets for telemedicine. Scroll through and see which datasets are of interest to you. So I'm going to be getting the first one, telemedicine use in the last 4 weeks. The purpose for this dataset is basically to rapidly monitor recent changes in the use of telemedicine. Download the CSV file, click CSV. The file has downloaded, so I'll double click on it so we can see what it looks like. I'm going to insert a table. Here is what the dataset looks like. It contains columns such as indicator, the state, subgroup. I'll save this to my desktop, hit save, and then I'll save as, create a new folder, and I'll call that Python database. I'll rename the file to telemed, and then I'll hit save. Launch Jupyter Labs. To launch Jupyter Labs, launch the Anaconda navigator, and from there we'll launch Jupyter Labs. Type Anaconda, open the Anaconda navigator. Anaconda navigator is initializing. Once it opens up, we are going to launch Jupyter Labs. Here's the Anaconda navigator, so I'm just going to X out of all of this. And then I will scroll down and I will launch Jupyter Notebook. If you don't have Anaconda installed in your computer, watch my last video on how to install Anaconda on Windows and then go through the process and install Anaconda so you can follow along and learn how to use Jupyter Notebooks for data visualization or Jupyter Labs if that is of interest to you. So once you launch Anaconda Navigator, scroll down to Jupyter Notebook and click Launch. We are going to be doing this data visualization using Jupyter Labs. Here on the localhost, I'm going to click desktop. On desktop, I'm going to launch Jupyter Labs. To launch Jupyter Labs, I'll go to New, Terminal. And then on Terminal, I'm going to type Jupyter Labs. Jupyter Lab. Then hit Enter and wait for Jupyter Lab to launch. Would you like to receive official Jupyter news? Please read the privacy policy. I'm just going to X out of that notification. So here within Jupyter Lab, I'm going to open a Python console. Click on Python. This will open a Jupyter Lab console. You see, this is similar to Jupyter Notebook, but this is a Jupyter console. You have cells within it, similar to Jupyter Notebook. I'm going to rename this Jupyter Lab console as test. I will right click and click rename it as test. Now that we have the Jupyter Lab console open, we are going to begin the process of the data visualization in Jupyter Lab by importing the necessary Python libraries that we are going to use. We are going to use two key libraries, Pandas and Pywedge. Pywedge library will give us the ability to create the graphs. From here, I'm going to start by importing Pandas. Import Pandas as PD, and I'll also import Pywedge as PW, and then run this. We are receiving an error. It says no module named Pywedge. This is because we haven't installed Pywedge yet. So Pywedge using pip install Pywedge. Pywedge is installing. Pywedge was successfully installed, and we are going to use this to do graphing of our data. Now that we have installed the Pywedge package, we are going to import Pywedge as PW, and then we are going to import Pandas as PD. The next thing that we are going to do is to create a data frame that will read in the file that we downloaded. Make sure that your Jupyter Lab console is within the same folder where you save your data file in, because if it is not in this location, it's going to throw you a lot of errors. Now we're going to read in this data file within Jupyter Lab. So we will create our data frame, call it TM for telemedicine, will be equal to PD read underscore CSV, open parent, and in single quotes we're going to type in the path to our file, python data.gov/telemed.csv, and then we close the parent. Run the selected cell. I'll just click run. Okay, to display the first 5 records, I will use a print function. Print tm.head should display the first 5 records. Then I'll click run. You can see that it is printing the first 5 records. To see the last 5 records, I can use the same function. Print tm.tail will give me the last 5 records. So here you have the last 5 records. I'm going to create an index for the column names. To create an index, we use the index function. Index, indicator, group, state, subgroup, phase is the next column, time period label, time period start date, time period end date. The next column is the value, low CI, high CI, confidence interval, quartile range, and finally suppression flag. And then we'll close the list and close the parentheses. Click run. Name index is not defined, so index is equal to this, and then we'll click run. Continue by creating a new object, call it vis, short for visualization, will be equal to pwpywedge package that we imported earlier dot pywedge. Make sure that the P is uppercase underscore charts. The C is uppercase as well. Open parent, bring in our data frame that we created, and then C will be equal to none. It is equal to none because we don't want to delete any columns. And then our Y will be equal to state, one of the columns within our data set. Close parent, and then I'll hit execute. Disregard this message, is just a warning. It's basically a reminder that in future versions of Pandas, all arguments of data frame.drop except for the arguments label will be keyword only. This is not actually going to prevent your code from running. You don't have an error. We're going to proceed by creating another object called visualize to allow us to visualize the data. You can call it whatever you want. Visualize, go to vis.make underscore chart, and then we close run, click run. In each window you can make about 4 different plots. So you have scatter plot, pie chart, bar plot or bar chart, violin plot, box plot, distribution plots, histograms. It's very easy to make plots given that we have connected to our data. So we are going to begin by making a basic scatter plot. To make a scatter plot, select the fields that you want to include in your plot. The x-axis for this plot will be value. The y-axis, I will keep it to time period. Then the legend color will be by phase. After you've selected the fields that go into your plot, just click make chart. This is our scatter plot showing this data over time. If you want to change the look and feel of the plot, maybe the distribution, you can select different values and then make plot again, and it will show you, let's say by suppression flag, and then we'll make plot. You see how the color changes. If you want to do it by a different thing, maybe by high confidence intervals, and make plot again, you see how the chart changes again. So here is our first scatter plot using the Pywedge make charts feature. Now I'm going to move on to how to make a pie chart. On the pie chart tab, to make a pie chart, you select your fields. I'm going to leave it to the indicators, and then I want to make a pie chart of the indicators by value, and then make chart. As you can see here on this simple pie chart, 58% of adults had an appointment with a healthcare professional over video or phone in the last 4 weeks, and 41% of households with children also had an appointment over video or phone in the last 4 weeks. Let me make another pie chart. On each of these windows, you can create 4 different charts using the same chart type. I'm going to create a second chart here using the subgroup. Select this. The values will be by suppression flag and click Make Chart. Here you have 2 different charts showing the distribution of the data that you can include into your presentation, or you can look to interpret how many adults had an appointment or how many households or children had a video or a phone appointment. Given that this is a telemedicine dataset, you can see the distribution here, and then you can interpret that whichever way you want. I'll just make another chart by phase, showing the distribution by state. You also have the option to create bar plots, and you can also go through and just select the fields that you want, create your bar plot. The violent plot is another graphing type. I'm just going to show you how to create the violin plot. So I'll leave the x-axis to phase, and then the y-axis to time period, and then the color distribution. I'm going to select interquartile range, and then I'll click Make Chart. This is what the chart looks like. Let me create a second one. I'll use the phase field, and then here I'll go by value, and then the color tool will be interquartile range. Create chart. Now this is what it looks like. Without interpreting, I'm just showing you how to create different charts in Jupyter Labs using the Pywedge package. Let's move on to another type of chart, which is the box plot. For the box plot, creating a chart is the same. Just go ahead and select whatever fields you want and click Create Chart. For this example, I will leave the x-axis to indicator, the y-axis to phase, and then the color to indicator as well, and I'll click Create. This may not be the best fields for a box plot or the data type for a box plot, so you have to be selective with what kind of charts you're creating. Distribution plots. In this case, I'm going to create an example using the time period. The y-axis will be values, and then the color distribution will just be indicator. I'll do Make Charts. Again, you can see the distribution of households where children had an appointment with healthcare professionals over video or phone, or where adults had an appointment with a healthcare professional over video or phone. And it's basically showing you the distribution. If you hover over, you can see the details. For now, I'm not trying to interpret these graphics. I'm just showing you how to create them. And then a histogram is the last type of graph that I will show you how to create. X-axis will be indicator and create. So here I'll go create, and then you can see it is showing me a graph of the same information. So this may not be the good type for this, so I'm going to change it to value, and then I'll make chart. And so you see, this is how this graphic type will look like. So it's basically a count of the values. So this may not make sense, as I said, but it's just to show you how to create these graphics using the various plot types. Let's change it to something else, maybe subgroup. So a count of subgroup may make sense. Yeah, so this may make sense, but again, I'm just showing you how to create these graphics without any interpretation whatsoever. And then here is another graph. This is just a count of states, and there is a big outlier here on United States. Before I log out, I want to show you one more thing. Let's say you created this graph and you like to use it on your report. You can easily just download it as a PNG file, download as an image, and put it on a report. So you click download. You have the new plot here. Again, this may not make sense. I'm just showing you how to create different plots, but your reports will have to make sense. Once you're done within Jupyter Labs, sign out and end the session. Go to File, click Shutdown or Log Out. Come to your Jupyter Labs session and log out of it. Don't forget to log out of Jupyter Notebook and also close out your Anaconda distribution because it is currently running. This is the end of the video. If you like it, please comment, share, and subscribe. I'll see you in the next one.